Hello. Let's talk about procedural modeling. Let's say you need to create some kind of profile to be used later with sweep node or revolve node. Basically something like piece of pottery, column, street light, or whatever cylindrical shape with the profile you need. Usually the way to go about this is to create line, add a resample it quite a bit because we will need a precision, and add curve view attribute, and then something like simple attribute warp or attribute wrangle, and let's say set the position x to plus equals tramp from curve view called, I don't know, ramp. And as soon as you do that, you have control over your shape. You can multiply this by some kind of a value, for example, channel width, and you have decent enough starting point. You have, for example, too many of points and you need to reduce it. You will use facet node to fix that. However, right away you can see the issue. We have unneeded points and we explicitly stated that actually here we need only 1 point, not 2. And you see it's kind of unstable and it depends on the amount of points in your line. So basically you will have too much of a points initially. And if you will go low enough with your point count, you will see that at some point the facet node will break the shape entirely. So you have to be careful with that. But in my opinion, it's not the best option to do this kind of tasks. However, with, for example, something like B-spline, it would work nicer and Facet will nicely get rid of unneeded points on our profile, and then we can use some kind of revolve and it will work fine. But what I prefer is more control, and let's do pretty much exactly the same, but in reverse order. We will sample our ramp position to create new points on the line. Let's create attribute wrangle. Let's set it to detail. Let's call it profile generate. Let's create ramp parameter in the interface. Let's call it ramp shape, for example. And don't forget about label, ramp shape, apply. And let's analyze what ramp parameter is actually doing in general and what controls the ramp itself. As you can see, we have some amount of points. In our case, it's 5 points. Each point has its own index, and each point has the set of controls that contains position, value, and interpolation. We care about only position and value at the moment, and let's inspect the names of these parameters. So as you can see, the name consists of 3 sections, first of which is the name of our current ramp. In our case, it's ramp shape. Second part of the name is number of point, so point number. And it starts from 1, which would be useful information a little bit later for us. The last part of the name is identifier, either it position or value or interpolation in this case. So we have pos and value as third part of our names. We need to reconstruct the name of each parameter for each point. Let's do so. Let's start with adding integer parameter called iters, and it will hold the number of points that we have. To get that from ramp parameter, we can use a little trick. We will evaluate this as a channel integer, and let's call our ramp name. I will store it in separate variable equal ramp shape. This is for simplify using it later when we, for example, need to rename our ramp or reference some other ramp on other node, let's say. And in channel integer function, we will feed our ramp name parameter. Next, we will create loop for. Let's initialize our iterator variable. It would be as usual, but it would start with 1. Second, we need the condition of the for loop, and it would be I less or equals iters. Why not less? Because we started from 1. And then let's add 1 to our iterator. Let's get the values. So let's create float position, and it would equal function channel. And let's construct the name of a channel inside of parentheses. We will use function called concat, which will construct strings from different parts. We can use 2 or more than 2 arguments to this function. And in our case, as we mentioned before, it will start from ramp name. Then we will convert our iterator variable to string in order to this function work properly and not throw in an error. And the last part of this expression would be the identifier. So it would be pos in this case, and second variable would be value, and basically the same expression as before, but with value instead of pos as a identifier. And let's actually test if we have proper iteers before we go on. Let's go to the geometry spreadsheet and choose detail, and let's save iteers as a detail attribute. Right now we have it equal to 5. We add points, value increases, so we can assume that this is working properly. And for each of these iterations we will create a point on our empty geometry. To do so, we need to initialize the integer variable which will hold the index of newly created point. And to add point, we will use function add point. We will create it on first input. We will set its position. The second argument would be the position. And we will use set function to create a vector. And we will use value as an x-axis and position as y-axis. And that we will leave equal 0. Let's see what it will give us. So as you can see, we have some points which somehow react to changes in ramp, which is nice. Let's actually create a primitive polyline that will hold these points. To do so, we need to initialize the primitive. Let's call it prim_num. It will hold index of newly created primitive. And function would be add prim. First argument would be the geometry. In our case, it's always 0. And second argument would be the type of newly created primitive, and we will use polyline as a type. We can use also poly and it will create closed geometry, but we need just a curve, so it would be polyline. Add primitive function has more arguments, but it's also valid to use it in this form, so it would be empty container, and on each iteration here we will add point to our empty container using function called add vertex. Add vertex expects from us, as usual, geometry. Secondly, it receives the number of current primitive on which we will create our vertex. And last one, the point the vertex would be created from. I've made a mistake because it's a prim_num here. Prim_num. Sorry for that one. And yeah, now we have line. And what's nice about this line that it would work precisely and it won't create any additional unneeded points, and we can easily create complex shapes, even create our own little bevels. Also, we can add some control to define the height and width of our profile. To do so, we will create two variables. It would be float h, channel h, for example, and float w, and the same channel. Actually, you want to call this height and width, but I don't want to waste your time. And we can multiply the value by w and position by h. Let's create these parameters. Let's set it to something else than 0. And now we have super convenient profile generator. And you can use it with revolve. You can use it as a sweep profile to get something like this. You can convert it to, let's say, NURBS curve and get precise amount of control. And after that, you can use resample if you need something smooth. And the same way as before, you can use facet. But the difference would be more precise initial control and way to get precise linear maps, which would be useful for all sorts of things. Thank you. See you in the next video.